Welcome to video 2 in our series of instructional videos for the basic use of VCarve Desktop for your iconic CNC machine. I am your host, Steve Stevenson, and it's our pleasure to bring these videos to you with the hope that it will help you to learn the basic functions of the software and get you on your journey to enjoying your CNC machine, and hopefully it becomes not only an enjoyable but a profitable experience for you. So as you can see, I've got VCarve Desktop open on my computer. And in this video, what we're going to teach you is what's called bitmap-to-vector conversion. So let's talk very quickly about the difference between a bitmap and a vector and why you need to convert them to use them in VCarve or virtually any CAD software program. So a bitmap is basically, as the name would describe, is an image that consists of bits of color. If you combine all those bits of color together, it gives you the image that you can view. It is used extensively in the internet, in the publishing world. Virtually any image that you would see online would be a bitmap. They tend to be very small files, so they're easily loadable on a web page, for example. But they inherently have a problem when we are dealing in CAD software, in that they're not precise and they're not defined lines with which we can create machining toolpath. If you think of a digital photograph, if you took a small digital photograph and blew it up into a large digital photograph, it becomes what we would refer to as pixelated, which becomes a problem because it becomes very difficult to identify what that is. And that is an issue when it comes to CAD software. CAD software works in more precise dimensions. In CAD software, for example, you see as I have VCarve open, if I create a new file, I'm just going to quickly open a page. And I'm just going to draw a circle. And I'm going to draw a circle 1 inch in radius, so it's a 2-inch diameter circle. And as you can see, if I zoom in on that circle, you can see the edge of the circle is, the geometry is perfect. It's not pixelated like you would have if it was a bitmap. If I was to take that circle and select it and change the size of that circle from 2 inches to 12 inches, so I'm going to make it quite a bit bigger. And I'm going to apply that. Let's just zoom out so we can see it again. Now let's zoom in on the side of that circle. As you can see, nothing changed. The geometry is exactly the same. There is no pixelation. A circle is a circle, a line is a line, an angle is an angle. It never changes. So scaling a vector is not an issue because it never changes at all. And so the big challenge is I want a bitmap to become a vector, and most CAD software programs have no capacity to do that. VCarve Pro is an exception. It does it, and it does it quite wonderfully and very easily, and that's what we're going to teach you to do today. So let's just close this back out. I'm going to open up a web browser. In this case, I'm using Google Chrome. You can use any web browser that you want, but I do suggest that whatever web browser that you're using, that you go to Google to perform the next operation that I'm about to show you. And you'll see why as we go through this. Google provides us with some very interesting information that we'll find quite helpful. So, in my search bar, I can type in virtually anything. You can choose to type in what I'm about to, or if you're doing this video and you want to find something else, favorite sports teams, logo, something that's your hobby. If you're a hunter and you want to look for a Browning logo, or a fisherman and you want to find a piece of line art of somebody bass fishing, certainly can do any of those things. And typically there's so much information available online that you're probably going to find something that relates to whatever your hobby or interest is. So in this case, I'm just going to type in something simple like Chinese line art. And you'll see that across the bar here, you can see several pieces of line art. But if I click on images, there are going to be thousands, or in many cases millions, of pieces of line art, in my case, or logos of your favorite sports team or whatever you're looking for. Now, there are several criteria that we will look at in terms of how to evaluate these images as you're looking for them. So you can see that there are all sorts of different images here, all kinds of different pieces of artwork. The one thing that you'll notice is that as I move my cursor over each one, a little window pops up and it tells me what the resolution is, or what's the pixel count is, what it's actually defined as, of each of these images. So this one is 800 by 451, this one's 599 by 873, and so on. Some higher, some lower. The higher the numbers, the higher the resolution. The lower the numbers, the lower resolution. Typically, you want nothing short of 300 by 300 pixels. You don't want to have anything smaller than that, or you tend to find a very pixelated image that will be difficult to get the right amount of detail when you do the conversion. So as you can see, all of these images that we're looking at here meet that criteria. If I just scroll down to, and you can typically tell some of them by how small they are, not always, but sometimes the smaller ones will actually be much lower resolution. There doesn't really appear to be anything in this list that's too tiny, so we may not find any that are too low a resolution. They all look pretty detailed. The other thing that you want to look for is you want to avoid anything that has what I would refer to as a gradient or a graduated screen. In other words, changes in shading of a color or of a grayscale. For example, if I took out the word line art and just typed in Chinese art, what you're probably going to find is very different images. As you can see, we've got some very interesting and beautiful images here. The problem with them is that many of them have this graduated screen that I just referred to. If you notice this one here, for example, look at the graduated screens, the changes in shade from one color to the next. So what the software is going to want to do is it's going to want to separate out these shades and basically define lines where it's going to separate those colors. And if there is no defined line, it's going to be very difficult for the software to evaluate that and determine where the best place to sort of separate the black from the white is, because there is no black and white. So in a perfect world, when you're looking at images, black and white would be the perfect solution. It doesn't have to be, but it's the perfect option for you because it eliminates all of those other colors. So if there is no grayscale in it, then it's going to be very easy for the software to make that determination. So let's go back to Chinese line art again. So based on what I just mentioned to you, you can see, for example, this one here would be somewhat problematic. The third consideration is you want to try to stay away from anything that has really finite detail. And it's not because your machine's not capable of getting that detail. It absolutely is. You have two issues. Number one is it doesn't become as impactful. For example, if you're doing a carving, say we're doing a trivet on a piece of wood, and you machine something as detailed as this, it would certainly get all that detail, but it really wouldn't have a lot of impact. It would be so fine that it would almost not be distinguishable from any distance away. The other issue that you have is, just if we're clicking in on this one as an example, where you're looking at all these these really fine lines. When you machine these, you'll literally be machining these to 2 or 3 thousandths of an inch. If you don't have a piece of material that's absolutely flat, and anybody who's worked in woodworking for any length of time knows that there's no such thing as a flat piece of wood. If you have a piece of material that's not absolutely dead flat, then you're going to have some areas that are going to over machine, some areas that are going to under machine, and in fact some areas that may not machine at all, because at 2 or 3 thousandths of an inch tolerance for error, it just may not happen. So those are the three main criteria that you want to consider. So as you consider those three main criteria and look at the images in front of us, you see a couple that sort of pop out as obvious choices that really meet them quite well. You've got this one here that you can see it's got nice thick lines. It has good detail, but not really fine detail. And the resolution at 600 by 593 meets that minimum 300 by 300 dot per inch requirement. So that's one that we could choose. If you scroll down a little bit further, you see this one here. Again, 900 by 606, good, fine, good definition. I like, for example, that you've got sort of these crisp corners. That's going to machine very well. But you don't have that really finite detail. So when you machine this with a little bit of stain or color, this would become very impactful. It'd be very noticeable from a distance. So based on my experience, those tend to be the ones that would work the best. I think we'll go with this one. And we're going to click on View Image. And you want to make sure that you click on View Image so that the only thing you see on your screen is the actual image itself. And I'm just going to right click and I'm going to save this image. I'll save it to my desktop, and we'll just call this Chinese art, or how about Chinese dragon? And we'll save that. Let's go back and open up VCarve desktop now. So now we're going to click on create a new file, and we're going to set our material up. So this is our job setup. We're going to set up our material. We'll leave it at 10 inches by 10 inches. You can see the X and Y. I can change them independent of each other. We can set our material Z0 to whatever we want it to be, or Z0. I'm going to set it to 3/4 of an inch, so that's my material thickness. My XY datum position, or my start position for this project, with an iconic machine, as we did in project 1, I'm setting it up in the top left corner because that's the home position on my iconic. I am not required to do so. If I choose, I could rather set it up in the center. I can do that. I just like the top left corner because the machine's by default is going to go to the top left corner when I send it to the home position. We're going to work in inches versus millimeters. And as we mentioned before, in the first video, we can set our modeling resolution to anything that we want, from standard to very high. If you have an older computer, be very careful with setting that too high, because it will just make it more difficult for it to be able to give you a rendering without taking, if you don't have enough system resources, it may not be able to generate that. So I've got it set at high, which I find gives it significant detail without having to, kind of get crazy using the system resources to create that 3D preview. And as you can see in the appearance, I can change the material to any substrate that I want. I find the Canadian maple is a good choice. It gives us the ability to see the image in a wood grain, but you can change it to anything that you want. So if you're going to do this in maple or in oak or in a piece of brass or whatever the substrate is, you can actually see what it will look like in the substrate that you're choosing. And then we're going to click OK. Now we're going to use a function in the software that's called import. Now you see there are two options. One's called import vectors from a file, and the other one is import bitmap for tracing. This is a bitmap, so we want to select the import bitmap for tracing and go to our desktop and scroll down, and we should see our Chinese dragon right here. So you can see there's the image, and you can see it's not exactly scaled to the size that we want it to be. As a general rule, I try to make sure that I don't change the scale of this until after I have converted it. And the reason being, back to the original description of a bitmap versus a vector. A bitmap, if you try to change the scale, will create more pixelation. A vector will not. So if I leave the image the size that it is and convert it, I have a better chance of maintaining the detail in it without distortion if I scale it after I convert it. So I've got my image, and now I'm going to use a function down here in the Create Vector section called Trace Bitmap. Now you see there are a couple of options in terms of how to trace this. I can do it as a color image, or I can do it as a black and white image. In this case, it hardly makes a difference because this is essentially a black and white image. But you can see that there are actually 16 different colors within this image, or 16 different shades, and we want to get it to the smallest number that we can get without losing detail in the image. As a rule, whether I'm using a color or a black and white image, I tend to like to switch it to black and white. Now you can see using this threshold bar, if I slide it from one side to the other, it changes the detail. Let me just zoom in on this so you can see it a little bit better. As I change the threshold to maximum, you can see that it sort of darkens everything up. So basically it's taking everything that is not absolutely white and it's converting it to black. If I move it the other way to the minimum, the opposite happens. What I'm trying to do is I'm trying to sort of split the difference. I'm trying to create lines that give me as much detail without losing some portion of my image. In this case, sitting somewhere around the middle seems to work about the best. So I'm sitting at about 0.53 in that threshold. You see that I have an option to change the corner fit. So the default corner fit, if I click on default, you can see that it's set at 82%. And the noise filter, or it's like a pixel filter, is set also at 2 pixels. So basically what the corner fit means is that wherever you see any pixelation on these corners, I have the ability to affect how it's going to respond to those. I find the default settings tend to work very well. The noise filter, same thing applies. Anything that's where you have small amounts of pixelation, anything 2 pixels or below is going to basically be filtered out. Anything larger than that will be kept. And again, those defaults tend to work quite well. And then the fading basically just gives me the ability to see what that image looks like a little bit sharper by increasing that fading. And we're going to preview it. And you can see as I preview it, it created the vectors around. And now if I want to change that fading, I can scale that back down. I want to zoom in so that you can really see what just took place here. Where you had pixelation, let's increase the fading a little bit. Where you once had pixelation, you can see what it's done is it's rounded off those, sort of taken all the highs and lows of the pixelation and changed it so that it creates nice smooth radiuses. However, if you see in the corner, where we had a fairly sharp corner before, it maintained that. Now it's not a perfect corner, but it's quite sharp. If I wanted to make that sharper, I could adjust this corner fit a little bit to see if I could make it a little bit tighter. But to be honest with you, zoomed in as tight as we are, it's absolutely going to be just fine. So then the last step in the process is to click apply. And now what I've done is I've converted the bitmap to vectors. And once I've done that, if we zoom back out again, I now can select the bitmap and very simply delete it. Because I've already converted it from bitmap to vector, so that process is done. I no longer need that bitmap any longer. Now I can scale this to any size that I want. So let's close our bitmap to vector window. Let's grab our entire image, and we have two choices. We can either double click on it and just grab it and drag it to the size that we want, or we can actually go over here to the set size of the object. So if I click on this, I can set my object size to any size that I want. In this case, let me make it, say, 8 inches. And we'll apply that. And lastly, I can center that in the middle of our material and close that. So now we've taken a bitmap that we found online, and we've been able to convert it to vectors. And the last step in the process for us is now to create the machining toolpath for it. So we're going to switch from the drawing side to the toolpath side. We're going to use what's called a VCarve engraving toolpath. We talked about this in video 1. We'll talk about it again. The VCarve engraving toolpath allows you to machine something and create the geometry exactly as you see it. So in other words, where you have fairly sharp corners, the tool will literally swoop out of those corners, and using the V-bit, as it does that, it will create the sharp geometry so that you retain those sharp corners. So the image will be as you see it. If you use any other toolpath for machining a logo, a line drawing, some text, the corners will not be corners because you can't put a round tool in a square corner unless you use the V-bit carving toolpath. So we're going to use a V-bit engraving toolpath. We're going to set our start depth at 0. We can choose or not choose a flat depth. I'm going to show it to you both ways just so you can see the difference. So in this case, I'm going to not choose a flat depth. We're going to choose a 90-degree 1.25" V-bit. And we're going to calculate. And let's just do a quick preview and see what we have. So if we preview all the toolpaths, you can see, now I've got the global fill color on right now, so let's switch it back to material color. You can see as I rotate this on its side what's happened here. So you can see that it's machined all the way down. So what tends to happen with this V carving toolpath is where you have areas that are wider apart. As you can see the distance between these two vectors here. It's going to machine till the 2 points of the V meet. What that means is where you have areas that are closer together, like for example, say here, it does not machine as deep. And as you can see in the 3D preview, that's exactly what happened. Machining much deeper here and less deep here. Now, let me just show you what would happen if we go back to our toolpath and just double click on it. We're going to go in and make one change. We're going to change our flat depth to something small like 1/8 of an inch. And we're going to recalculate this toolpath, and we're going to reset the preview and preview all of our toolpaths. And now you can see how it's very different, because what's happened is that at 1/8 of an inch, we've basically said we don't want to machine any deeper than that. And it basically can change the drawing fairly significantly. The other thing that changes is the amount of machining time, because we usually are using 1/8 inch passes for machining depth. So if I'm going to machine to a 1/2 inch depth, it's going to take 4 passes to machine this project, versus in this case, I've done it in a single pass because I'm only doing an 1/8 inch maximum depth. So that's really discretionary. It's depending on what your preference is or what you're trying to accomplish with that particular project. And again, as you saw from the beginning, I can put in global fill color so I can see what this project would look like if it was going to be stained or painted. Lastly, we want to save the toolpath so that we can machine it. So we're going to go over here to Save Toolpath. We're going to output all of visible toolpaths to one file. If we're using the iconic machine, we can do that. With a general or an Oliver machine, we cannot. We would have to uncheck this and save toolpaths separately. In this case, it hardly matters because we only have one toolpath. But if it were a multi-tool operation, then we would have to save it as separate toolpaths. But the iconic machine can do it in a single toolpath operation. In this case, we're using the post-processor GTEC ATC Inch. That is the correct post-processor for your iconic machine. If you're using a general machine, you'll see that there is an iCarver post in the directory here. Just scroll down to it. So here you can see iCarver inch and iCarver millimeter for the iCarver. That same one would be used for the Oliver IntelliCarver. So you can post out to those. But again, make note of the fact that you cannot use the you can't post all visible toolpaths to one file if you're using those two machines. So we've selected the right post processor. We'll click on Save Toolpath. In this case, I'm just going to save this to my desktop, and we'll just call this Dragon and save that. So we've now saved our file as an NC file. As we mentioned in video 1, you can put that NC file directly on a flash drive, take it to your machine, and create a machining toolpath for it. Or if you prefer, you can open that NC file in iPicture. We'll show that in a future video. You can open it up in iPicture and convert it from an NC file to a .gee file. The two files are identical, the difference being that the gee file activates the border function on your iconic machine. So if you want to do a quick border check before you actually machine the project, then you need to convert that file from an NC to a gee file. If that's not a concern for you, put the NC file straight on your flash drive, take it to your machine, and happy carving.